everybody, this is Mrs. Wild from your WCA Astronomy class. Today I'm just going to go through with you how to do the portfolio. We're actually going to be doing this one, the motion of the sun. I'm doing a re-record on this one. And I'm going to have you click on the worksheet that is found on the intro page here. And that is going to bring you to this worksheet. So you'll have to make a copy of this worksheet. You're going to either go to File, make a copy, and that only works if you're logged into Google Chrome. If you don't have a Google Chrome login, just go to Download and download it to Word, and you can open that on your computer, okay? Now, what do you need to do for this? We're going to be modeling the position of the sun as it rises and sets throughout the year, and kind of looking at its tilt and how high it gets in the sky. First thing you need to do is find your longitude and latitude using this link, and then you can enter them into the next link, okay? So this brings you here, and I've already put in my latitude and longitude, about 44 degrees. North latitude, this one you don't use N or S like north and south. You're using a positive and negative. So if it's south, it's negative, or east and west. We are west, so it is negative, okay? Just so you know. It will tell you that it'll use the same notation in the other website. So the first thing you're going to do is you're going to try to determine the direction of sunrise and sunset, and then the altitude of the sun, and how the tilt of the Earth is. This is the tilt of the Earth here, okay? So let's do that first. Let's change this to March equinox. So everything kind of is set for March equinox. And then the first thing I want to know is the position of sunrise and sunset. And that's going to be this yellow line here, okay? So this yellow line here on this left, bottom left, is showing you sunrise and sunset. So you're basically just going to be watching. You can kind of see where it intersects sunrise or sunset, okay? Where does the line actually hit the horizon? Now I know this isn't exactly perfect here, but I would still describe it as the closest approximation. So northeast is going to be about here, about 45 degrees between north and east. And southeast is going to be about 45 degrees. So here, even though it's not exactly on the red arrow, I would still describe it as rising in the east and setting in the west, okay? Now, as far as the altitude, you're going to use the little lines that are found on the celestial sphere. And they're kind of hard to see, but kind of bear with me. The very top, or the zenith of the sky, is 90 degrees. And every time we go down a circle, it is 10 degrees down, okay? So 90, 80, 70, 60, and what we're looking at here is the sun actually, and I can kind of play this. You can kind of see this. I'll try to pause it in a second as soon as it gets to its maximum altitude. Okay. So it's getting up about 90, 80, 70, 60, probably about 55 degrees, because it's kind of halfway between the 60 and the 50 mark. Do you see that? So that's kind of giving us where the maximum altitude should be. Then we can look at, and I still want to go back to March equinox here. Oops. Make sure that we're in the right spot because time is running. I want to look at this one. So as you can see, this is where the Earth is. Do you notice that the axis of the Earth is what we're concerned with? Is the axis of the Earth pointing towards the sun, away from the sun, or is it kind of sideways to the sun? Okay. So sideways to the sun means all parts of the Earth on the sun side are receiving kind of an equal amount of it's kind of evenly distributed, I should say, with the equator getting the most sun and the poles getting equal amounts of sun, if that makes sense, okay? So I want you to kind of look at that here. Is it towards, away, or kind of sideways to the sun? And that's what you're going to put here. So we had the sunrise, the sunset, the max altitude, and orbit would be either towards, away, or sideways to. Okay, and you're going to complete that for um, summer, fall, and winter. It might also note or another thing to note, I should say, is how long the sun spends in the daylight portion of the sky, okay, from season to season. How long, let's see, you can almost see the hours go by here, but how long is the daylight portion? So we can kind of pause it about 7 o'clock in the morning, and then pause it there, and about 17:55, which is, I don't know, about 10, almost 11 hours later. Okay. So it kind of gives you an idea that the daylight length is about 11 hours. We didn't actually have that in the data table, but that's important when you're doing your follow-up question. So once you're done with your data, I want you to use the claim evidence reasoning model to explain why the tilt of the Earth and the direction of sunlight and sunset contributes to seasons. In this part here, especially think about the length of the daylight portion. So when you're using claim evidence reasoning, you are going to state why. You're going to make a claim, like why the tilt of the Earth or that the tilt of the Earth and the daylight length affects seasons. You're going to explain why, what kind of evidence you've gathered from your lab, like you saw this information, you actually were able to measure daylight length or like where the sun rose and set, the path of the sun in the sky, how sunlight kind of hits it, and then I want you to give me some explanation, like why does the tilt of the Earth matter? Why does the daylight length slash direction of sunrise sunset matter? Okay, so kind of like 3 portions. It is worth 4 points. So like 1 point for the claim, 1 point for evidence, 1 point for reasoning, and a point for overall, making sense. Did you get it right? That kind of stuff. So this is what you're submitting to me. You're actually making a copy and submitting this sheet to me. And then that's it for this portfolio. So hopefully that makes sense. And thanks so much. Have a great day.